Traditional ways of inputting a password in a computer through a keyboard are vulnerable to shoulder surfing. Shoulder surfing refers to the usage of observation techniques to obtain someone else's password. In this work, we propose the usage of eye tracking technology to estimate a user's point of regard on the screen and using this mechanism as a way of inputting a password on a computer. Gaze tracking requires the user to undergo a calibration procedure which is user-specific and allows the gaze estimation algorithm to build a model of a specific user's gaze on a screen. The calibration procedure consists on the user just looking at a number of points on the screen. The purpose of this project was to carry out a user study to compare different gaze-based password inputting mechanisms with a traditional keyboard-based input method. We built a graphical user interface that shows to each subject involved in the study the list of different password input methods available. For illustration purposes, in this video we will superimpose a red disk indicative of user's gaze over the interface of the different password input methods. This feedback was not present during the real experiments, since doing so would defeat the purpose of creating a shoulder surfing resistant password input method. But in the context of a demonstration video, the red disk helps to illustrate the concept of how to use gaze to input a password. The keyboard-based password input method consists on the familiar typing of a text password using the keyboard. The gaze-based number pad password input method consists on displaying a number pad on a screen and requesting the subject to gaze to a predefined number sequence. The gaze image password consists on displaying a familiar image on the screen and asking the subject to look at a sequence of spatial locations on the image. The gaze gestures password consists on displaying an empty screen and requesting the subject to carry out a gaze gesture with his gaze. The object track password consists on the user tracking a predefined sequence of randomly moving objects on the screen using a smooth pursuit's gaze movements. In summary, the introduced gaze-based password input methods offer alternative authentication mechanisms during human-machine interaction that are shoulder surfing resistant and very similar to keyboard-based password input mechanisms in terms of input speeds and error rates.